Hello.
What's everybody doing this morning?
Good.
Good. It's Thursday. All righty. Get everybody loaded in. Looks like 1, 2, 3, 4, 5, 6, 7, 8. We got everybody. All right. Go ahead and yesterday when we left off, we were working on section 1.7, so you can go ahead and open up there. Does anybody have any questions before we get started today? Any questions on anything? Very good.
Can you email me all this stuff? Like all the homework?
Okay, we didn't have any homework assignments from last night, but what I'll do is when I just logged onto my computer, evidently my posting of yesterday's class, for some reason it had not published, I don't think, to YouTube, so you'll just need to go back and watch that video. That'll go through all the homework answers. It'll go through everything that we covered yesterday. So you'll just need to watch that video. It should be, let me check real quick and make sure that it did, because when I yeah, it says video published, so it is there. So you can go back and watch that, and then that will get you all caught up. So anyway, we will go ahead and pick back up with 1.7. We were talking about our different formulas with perimeter, circumference, and area. Hang on just a minute. Do you need somebody? Look and see if Dad hung it on the fridge. Okay. Sorry, we're hunting masks so we can head to school. So we were talking about our perimeter, circumference, and area, and we wrote down the formulas for a square and a rectangle and a triangle and a circle. And we had started working with our rectangles and circles. Okay, so when we looked at a rectangle, we said that we know that we're dealing with length times width. And when I'm doing perimeter, I know that I have two sides that are equal in length and two sides that are equal in width. So all I do is add those four together. And then to find area is just to multiply the two together, length times width. Then we looked at finding the area and circumference of a circle. And we talked about how with a circle, when you have a point in the middle of the circle, you can draw a line from that point or from that circle, I'm sorry, from the middle point of the circle to any point on the line. And that's going to be your radius. Okay, so from the middle of the circle to an edge of the circle will be your radius. But if you connect edge to edge through the middle, that's our diameter. And we talked about how the radius is half of the diameter. We've also talked a lot about how in geometry, there's a lot of things that a lot of previous knowledge that we're having to bring into working problems. So it's the kind of thing that once they've taught us something, and then maybe they've taught us something else, there may be a problem down here that we've got to include all of those things that we've learned into that one problem, okay? So we can't think of each of these things that we're learning in isolation. We have to start putting them all together, okay? So, so those are going to be some things that we're seeing as we go through geometry, like yesterday when we were checking those homework answers, dealing with, you know, whether it was angle bisectors or whatever, dealing with a linear pair. A linear pair is two rays that join to make a straight line. Straight line equals 180 degrees. There's just a whole bunch of things that when we think of one thing, there should be a whole string of other things that follows that we go, oh yeah, this is this, this is this, this is this. So that's what's very different in our learning of geometry, okay? So, and same thing like with what we're doing right now, if my problem is asking for circumference, and we learned, actually, I thought I'd shared my screen, but I haven't. Let me do that real quick. Oh, did we lose Lucas? Nope, there he is. Share my screen. There we go. All right, So when we were talking about circumference and we said that the formula was 2 pi r, if we have a problem that is asking for the diameter, then what we have to do is we've got to understand that the diameter is 2 times the radius. Okay, so like I said, there's things in here that we have to start just remembering and understanding that these things are related. Okay, so we had talked about rectangles and we had talked about circles. Now we're going to move on to finding measurements of a triangle in a coordinate plane. So we know that a lot of geometry, we are dealing with coordinate planes. We're talking about ordered pairs. We can use distance using an ordered plane, using a coordinate plane, that we're going to see this a lot. And so kind of getting used to seeing our shapes and figures on a coordinate plane will help us. So again, now we've got to pull in all of our memory of a coordinate plane. We have the x-axis, that is the horizontal axis. The y-axis is the vertical. When I graph points, I have to move along the x-axis first and then up the y-axis. You know, just kind of remembering all of these things that we previously learned. So it says to plot the points in the coordinate plane. Draw the height segment DE as G. Point G has the coordinates 4, 3. So in this situation, they've told us that the point 4, 3 is G. So you can go ahead and plot that point, okay? And then they told us, so we can see here, they told us what points D at the top, where it says find the area and perimeter of the triangle defined by D1. So they told us the point for D1 was 1, 3. E8, let's see. Let me get my stylus that works better. Okay, so they told us that D1 is 1, 3, E is 8, 3, and F is 4, 7. So the first thing we would do is go ahead and plot those points, okay? That's the given. And then also in our problem, they've told us that point G has the coordinates of 4, 3. So if I were to plot all those points, D, E, F, and G, I can see where my points are. And then it says to draw the height from point F to side DE. So where I had, where I could connect my points, I would go ahead and connect and make my whole triangle. But you can see where I've got the line that's going from F to G up the middle, okay? Remember, we've talked about the area of a triangle is 1/2 base times height, okay? Your base is always going to be what your triangle is sitting on, okay? So this is going to be my base right there. But my height is going to have to be to my highest vertex of my triangle. I can't just use one of my slanted sides to show height. It's got to be from my base to my vertex, okay? So we're always looking for the height to try to figure that out. So in this triangle, to find base times height, what I've got to do is I've got to start, and I can do one of two things, okay? I can either subtract and do 8 minus 1, and that's going to give me 7, or you can actually count it if you want to and just say 1, 2, 3, 4, 5, 6, 7, okay? So you can see that you are 7 places from point to point. So I can see that the base is going to be 7. Okay, for my height, I can do the same thing there. Okay, for my height, I can either say, now I'm dealing with my y-axis, so I have 7 minus 3 is 4, or you can start at your point and go 1, 2, 3, 4, and you found that you are 4 places up. Okay, so all you have to do is count it on the grid, and we have found that our base is 7 and our height is 4. So then all I'm going to do is plug it into my formula, where I have 1/2 times 7 times 4. Okay. Usually what I do when I'm doing these, I mean, you can always use a calculator. Now that we're in geometry, calculators are perfectly acceptable. So you could always use your calculator, or what I'll do as far as quickness is I'll find my even number that I'm multiplying by and take half of that first, because I know I'm taking half of a number. It's obviously easier to do half of an even number. So I know half of 4 is going to be 2. So 2 times 7 gives me 14. Okay. Now, one of the things that's finding the area. Now, perimeter is not going to be so easy because notice when I'm doing this right here, these are not always going through perfect locations. Now that one did, but sometimes they're not, so I can't count my slant lines, okay? So to find perimeter, what I'm having to do is I've got to use the distance formula, okay? So to find the perimeter, I use the distance formula. So I need to find E to F. So I'm looking at, let me erase this real quick. So what I'm doing is I've got to find my distance from E to F. I've got to find my distance of my slant lines, okay?
Does it
from
matter which doesn't matter which one you like subtract by? Like it's 4 minus 8. Would it matter if I did 8 minus 4?
Yes, because 4 minus 8 is a -4 and 8 minus 4 is a +4. Okay, so it does matter. Remember with our distance formula, this is where we have y2 minus y1 plus, I'm sorry, x2 minus x1. Hold up. Y2 minus y1, no. Why am I saying this backwards? Okay, so they're using F as 0.2. Okay, now again, is what you were asking, does it matter if I use E or F as your point?
I'm saying like, does it matter if I use like x2 and y2 as 4 and 7 and x1 and y1 as 8, 3?
Okay, what does matter is if we are using point E and we have 8, 3 and F is 4, 7. It doesn't matter if I decide that this is 0.1 or 0.2. Okay, and then this could be the opposite one. What does matter is that you consistently use them in the right place. That if you're using E as 0.1, then you put it in the proper places. If you're using F as 0.2, that you make sure that it's consistent. Okay, so so in this situation, let me go back to something real quick. So I'm trying to make sure I say this as clearly as possible. It does not matter which point you choose as 0.1 or 0.2. What does matter is that you plug them into the formula consistently. Does that make sense? Did I say that better? So choosing your point is not the hard part. Making sure that you put it in the formula consistently is the most important, okay? Let me get on my right page of my book real quick. Trying to look back for something real quick, sorry. I was trying to see exactly what pages we were back on. So that was back on page 19. If you, and this is one of the things that I recommend, if you have a notebook that you can start keeping a consistent log of all your formulas as kind of a reference sheet, that would be fantastic, because they're not always going to give you the blank formula when they tell you to use it. So if you've got a lot of times if I've got a notebook and there's certain things that I want to keep in a special place, I'll flip to the very back of my notebook and I'll start keeping a log of things that I know that, hey, I can flip right back to the back of my notebook. So that would be a great place to put your midpoint formulas, your distance formulas, you know, the segment, what was it? The segment addition postulate, things like that for you to have a reference to. So anyway, that may be helpful. So, but the main thing is that when I'm using my, my formula, I know that distance is equal to x2 minus x1 squared plus y2 minus y1 squared. And like I said, it doesn't matter which point you choose as 1 and 2. What does matter is that you consistently put them in the formula. So you make sure that your 2s, your 1s match up and your 2s match up. Okay. So let's go ahead and take a look at that. So they ended up using F as 0.2. So you've got x2 minus x1, and then you have y2 minus y1. Okay, so like we said, 4 minus 8 is -4. -4 squared will be 16. And then 7 minus 3 is also 4, and 4 squared is 16. So you have 16 plus 16 gives you 32. Now remember, just for some practice, we'll go ahead and 32 would be 2 times 16. 16 would break down into 2 times 8. 2 times 4 is 8, and that's 2 times 2. So we circle up our buddies. There's 2 buddies. Those 2 buddies came out as 2 times 2. The radical of 2 is left under there. So this 2 times 2 became 4, and my radical stays under the radical. Okay? So again, they are assuming that you know how to reduce radicals here. They're not taking you step by step through it. I just wanted to show you to help you remember you've got to do that.
Could
Okay?
you do 4 times
Same thing
4
over here.
times 2?
Pardon?
To get that, could you do 4 times 4 times 2? Would that work?
Yeah, if you wanted to leave it as 4 times 4 times 2, and you know that the square root of 4 is 2 and the square root of 4 is 2, you're going to end up with the same thing.
Right.
Yeah. All righty. So then they did the same thing for DF. Okay. They looked at my, they looked at point D and point F. We needed to find the distance from D to F. So we had to use our distance formula. They chose F as my second point. And the way that we know that is by the way that they numbered the way that they lettered it. D, they are using as 0.1, F as 0.2. Well, I don't know what I did there. Go away. Man, sometimes I do things on this thing and I haven't quite mastered it yet. Well, where did my paper go? Let's do this. No,
Next week, do we have a test?
we do. We're going to be talking about that today. Here I am. Okay. Oh my goodness. Sorry. I don't know what these buttons at the bottom were, and I can't make them go away. We'll just deal with it for now. Okay. So distance formula that we're using here, we find that 4 minus 1 is 3. 3 squared is going to be 9. 7 minus 3 is 4. 4 squared is 16. So we're going to have 9 plus 16 is 25. Oh my goodness. I'm going to have to, hold on a second. Let me see if I can get this to go away. Ah, there we go. Here's the magnifying glass. My kids laugh at me. They tell me I'm as bad as the grandparents on technology. Okay, there we go. So we find that this one ends up being the square root of 25. We know the square root of 25 is 5. Okay, so now what we're going to do is we already know that, let me erase some of it. We already know that our distance, we found the distance of the bottom of our triangle. We already know that that distance was 7. Okay, so now finding perimeter, I'm finding DE, EF, and DF. So we found that DE was 7. We already knew that. Okay, then we found that EF was 4 times the square root of 2. Then we found that DF is 5. Okay, so now I'm going to combine my like terms. The only things I can combine here are going to be my whole numbers, 7 and 5. So 7 and 5 equal 12. And since I cannot combine 4 times the square root of 2, since these are unlike terms, I'm just going to write it as 12 plus 4 times the square root of 2. That is your final answer. There is nothing else you can do to simplify this answer. Okay, so finding the perimeter of a triangle, I have to use the distance formula for my slants. I already know my distance of my base because that's easy to calculate. Okay, but if I didn't, I could use the distance formula there as well. Okay, so perimeter area equals 1/2 base times height. And then to find my, area is 1/2 base times height, but to find perimeter, I may have to use distance formula. Okay, let's look at goal number 2. And that is going to be on page, what page are we on here? Let me make this go away now. Page 53. Okay, so goal number 2 says a problem-solving plan can help you organize solutions to geometry problems. Okay, so I think a lot of times when we are problem solving, we get a little hung up on what all's going on. And so if we have a plan, it kind of helps us just with anything that we're working on. If we have a way to go, hey, number 1, this is where I start. A lot of times getting started is usually the hardest thing to do. We look at a problem and we read it and we go, I got nothing. So if you have a plan and you say, hey, number 1, this is what I need to do, okay? And then you've got your steps to go through, right? Don't go into it cold trying to figure it out. Use your steps. There is nothing wrong with using the information you've been given, okay? So it says, step 1, ask yourself what you need to solve the problem. You can write a verbal model or draw a sketch that will help you find what you need to know. Just like if you were given that problem and you did not have that picture of that triangle that we just went through. If they said, hey, here are the points of my triangle, the first thing you should be doing is going ahead and drawing it out to make sure you understand what it's talking about, okay? Number 2, label known and unknown facts on or near your sketch. So draw on it. Write down what you know, write down and then make a, maybe make a list of the things that you're not sure about. Number 3 says use labels and facts to choose related definitions, theorems, formulas, or other results that you may need. So that's the kind of thing where you're thinking through all the like I said, the information that you know, being able to apply it all together to go, hey, this is what I know. This is what I need to know kind of stuff, okay? But this is where you're having to recall a lot of that information, just like, okay, straight line, 180, just, like y'all know I've gone through this a zillion times, that as one idea pops in your head, start stringing it along with all the other things that you know about that, okay? Number 4, reason logically to link the facts using a proof or other written argument. So one of the things that we are going to get into in geometry is writing proofs and having to prove, when I say I go from this step to this step, why? Why are you doing that? I need proof on why that is the right thing to do, okay? And then it says to write a conclusion that answers the original problem and check that your reasoning is correct, okay? So let's look at the example they've given us about a soccer field. Lucas, you'll enjoy this. Okay, you have a part-time job at school. You need to buy enough grass seed to cover the school's soccer field. The field is 50 yards wide and 100 yards long. The instructions on the seed bag say that one bag will cover 500 square feet. How many bags do you need? Okay, so there's a couple of things we've got going on here. One thing that I'm noticing right off the bat is we're talking about the area of a field. So now I'm popping my head, I'm thinking, okay, we've got a rectangular field. I know area is length times width. That's great. I can see that it's 50 by 100. Perfect. I know that I'm buying seeds. I know that they've told me information about how much each bag will cover. One thing, though, that popped out in my head as I was reading that was my field is measured by yards and my seeds are covered by square feet. So now I've got 2 different unit measurements here. So all by reading the problem, I'm kind of dissecting immediately, what do I know from this problem? What do I need to know? Okay. So you can see here, they said, okay, here's my verbal model. So you could either write it out, think it out, whatever. They said, I know I'm dealing with the area of the field. Okay. And we know that the area is 150 times 300, because they said, hold on. The field is 50 yards wide and 100 yards long. Okay, so what they ended up doing first was saying, okay, my bad. I'm trying to make all of this flow immediately. Verbally, I'm just going to start there. So area of field equals the number of bags of seed times the coverage per bag. So the first thing they did is they said, okay, when I'm looking at my coverage per bag, okay, I've got to change that to square feet, okay? So the first thing they did is the area of the field is going to be 150, because we're going to multiply 50. No, why am I confusing this so bad? Let me read the problem again, make sure I understand it. You have a part-time job at the school. You need to buy enough grass seed to cover the school soccer field. The field is 50 yards wide and 100 yards long. The instructions on the seed bag say that one bag will cover 5,000 square feet. How many bags do you need? Solution: begin by rewriting the dimensions of the field in feet. That's where I was jumping. I didn't even read that part, and see, that'll show you. Begin by rewriting the dimensions of the fields by the dimensions of the field in feet. So we've got to convert our yards to feet first, okay? And then that way we're working within same unit measurements. I was trying to set everything up first and then change my measurements instead of change measurements first. So what do we know about yards to feet? What is our conversion? How many feet are in 1 yard? 3 feet for 1 yard. Okay, so what they did is they said, hey, I know that 3 feet is equal to 1 yard. So what I'm going to do is I'm going to look at the area of my field, and I know that if I have 50 yards, that's going to give me 150 square feet, or 150 feet. If it's 100 yards wide, I am at 300 feet, okay? So now we've been able to convert our area of our field, so now we're multiplying 150 by 300. We do not know how many bags of seed we need, and so that is why they have let our bags of seed be in. That is our unknown information, okay? Now we're looking at coverage per bag. It already told us that each bag covers 5,000 square feet. So now I'm going to set up my equation to where I'm going to find the area of my field in feet equals N times 5,000. Is everybody good with me there? Sorry it took a minute. I just jumped right over that part in the beginning where we were going ahead and converting. So when I multiply 150 by 300, then we're going to need to separate N times 5,000. We do that by dividing by 5,000. So now we have 150 times 300 divided by 5,000, and we end up finding that we need 9 bags of seed. Okay, so one of the things we learned here is do your conversions first. Go ahead and set that up to where everything is in equal measurements first. Then set up what your equation is going to look like. Know that the area of the field is going to equal the number of bags of seed times the coverage per bag. Plug in your known information. In this situation, we knew how big our field was. We knew how big or how much seed we would have per bag. What we did not know and what we do not know will be used as our variable, okay? And then it says unit analysis. You can use unit analysis to verify the units of measure to where you can see that feet squared is equal to the number of bags times feet squared divided by bag, okay? All righty, now I bungled through that, maybe I'm awake. Let's look at example 5, using the area of a square. You've got a swimming pool, and it says you are planning a deck along 2 sides of a pool. The pool measures 18 feet by 12 feet. The deck is to be 8 feet wide. What is the area of the deck? Yay, we are already in same measurements, so we don't have to stress about that, okay?
Jennifer,
Yes.
how'd you get 9 bags?
Okay, calculator, 150 times 300. 150 times 300 is equal to 45,000. Then divide by 5,000 equals 9.
Oh, I get it now.
Yeah, so you would have to multiply. So this part right here is your problem that you're solving. 150 times 300, then divide by 5,000, and that equals 9.
I get it now. All right.
Okay. All right, so we've got our swimming pool. We know that our pool is 18 by 12, okay? And we want an 8-foot deck. So the first thing that we're gonna do is it says, what is the area of the deck? What question they're asking, I know is going to be my unknown, okay? That's what I don't know, that's what I'm solving for, so that's what they've told me here. My area of my deck is going to be A. Okay, I know that because of the length of my pool, I know that I'm going to have one deck that's going to go right here. And I know that I want it to be 8 feet wide. Okay, in my problem, they told me that I want it to be 8 feet wide. So I know it needs to come out 8 feet this way. Well, I know the length of that pool is 18 feet. So what I've done is I've said that if it's already 18 feet long and I need it to come out 8 feet wide. Now going up my other side of the pool, coming up this way, I know this is my 12-foot side and I want it to come out 8 feet as well. So now I have 8 times 12. Now the tricky part is this little guy right here. I don't want a deck that only comes off this side here and over here. I can't forget this little part in the middle. So I can see if this side is coming out 8 feet and this side is coming out 8 feet, I know I've got an 8-foot square that I'm going to have to fill in here. And so 8 times 8 is going to be that area of the square. Now remember, probably if you were trying to do this in your head and you didn't draw out the diagram, you're probably going to forget about this little square right here. You're going to say, hey, I put a deck on this side and I put a deck on this side, but we forgot about where those 2 decks meet, okay? So now what I'm going to do is I take my area of rectangle 1, my area of rectangle 2, and my area of my square, and I just multiply them out. 8 times 8 plus 8 times 12 plus 8 times 8, 8 times 18 plus 8 times 12 plus 8 times 8 is equal to 304 square feet. Okay, so drawing that diagram can be helpful so we do not forget parts of what we're looking for. But it's always helpful looking at what your question is, and once you get your answer, go back to your question in the problem and say, did I answer what it was asking? Okay, because sometimes it may be that we have to solve for X, but we have to plug X in to find a measurement or something. Make sure that with a word problem, especially, you're going back and you're answering the question that it's asking. Example 6, using the area of a triangle. You make a triangular flag with a base of 24 inches and an area of 360 square inches. How long should it be? Okay, so they've told us the base. We know what that base is. We know what the area is. What do we not know? How long it should be. Yeah, and in this situation, when we're talking about length with our triangle, this is the part of our formula that we call the height, okay? When we talk about 1/2 base times height, we know that's our formula. So they're calling the height the length in this situation just because it's turned sideways. All right. So know that those two words here are being used they're being interchanged. Okay. All right. So what we do is we know the area. So we're plugging that information in here. We know our formula is 1/2 base times height. So I'm going to plug in my base. I know 1/2. I know my base. What I don't know is my height, or my length, as they're calling it in this problem. So I plug in my 360. I plug in my 1/2 from my formula. I plug in the base information that I know, and this is what I'm solving for. I know 1/2 of 24 is 12. So now I have 360 is equal to 12L. I'm going to divide both sides by 12 and get that my length is going to be 30 inches. So the flag should be 30 inches long. So by knowing these formulas that we've worked with, I can back into them. I'm not always going to be just solving for area. I might be having to solve for a length or a width. I might be having to solve for a base or a height. I might be having to solve with my circles. I may be solving for diameter or radius. It's not always going to be solve for the circumference or solve for the perimeter. I may have to be figuring out what the sides are. I may have to work them different ways, just like we've just seen, where I know parts of my formula, but I have to solve for an unknown. Okay? So let's work through this guided practice a little bit. And this is going to be starting on page 55. Check our time. It is 9:12. All right. Guided practice number 1. The perimeter of a circle is called its what? When we did formulas for circles, what did we use?
Radius.
Circumference.
Circumference. Good.
Oh, yeah. It's circumference. Obviously, circle.
Yep, circle, circumference. Since a circle does not have straight lines, since a circle is round, we can't find perimeter of a circle because perimeter is by adding together the sides, the length of each side. Circles don't have sides. It's round. So we use the word circumference in place of perimeter for a circle. All right. Then it says, explain how to find the perimeter of a rectangle. Okay. What did we say was how we find the perimeter of a rectangle? We've got 2 formulas that we talked about that we could use for perimeter. And we said that
2 length plus 2 width.
Yeah, 2 times the length plus 2 times the width, or if you just want to say length plus width plus width, either way, okay? You can multiply the length by 2 first and then multiply the width by 2 and then add them together, or you can just add them all individually. All right, now it says to find the area of the figure, and where necessary, we are plugging in 3.14 for pi. All right, so we have a triangle here. What is the formula for the area of a triangle? Area equals 1/2 base times width. Base times width, good grief. Base times height. we can see that our base is 9. Our height is 8. So I'm going to have 1/2 times 9 times 8. Remember, like I said, I like to go ahead and say, hey, I can do half of 8. And I know that's 4. So 4 times 9 is going to be 36. And so when I'm dealing with area and perimeter, if it does not give me a unit of measure, I'm going to say square units. I'm just going to use the word units instead of feet, inches, miles, whatever, just square units. Or you could write it as units squared. Either way. You can either write the word square in front, abbreviate square, or you can do the units with the exponent of 2. All righty. Rectangle. We already said that area equals length times width. So I've got area equals 7 times 13. And that is going to equal 91 square units. All right, now we're finding the area of a circle. Area equals 2 pi r. Is that right? Is area 2 pi r? No. What formula is for area?
Length, W.
No, area of a circle.
Oh,
Number 5. What is my formula for area of a circle?
Pi r squared.
Pi r squared. Yep, I tried to give you the circumference one, see if we're awake. All right, area equals pi r squared. So in this situation, they told me to use 3.14 times, my radius is 3, so I'm going to have 3 squared. So area equals 3.14 times 9. When I multiply that, I'm going to end up with 28.3 square units. Okay. One of the things that I find helpful is to always start with your blank formula. That way, as you're working through the problem, you're making sure you're plugging in the correct information. Okay. So I'm not saying you always have to start with the blank formula, but to me, it just helps. So then if I've made a mistake, I can look back and go, oh, that's where I made my mistake. Okay. So that's always just kind of a helpful tip that I find. All right. Let me get some of this erased. Okay. So it says the perimeter of a square is 12 meters. What is the length of a side of the square? So again, we said that we know that when we're finding perimeter of a square, that all we're doing is adding our 4 sides together. So we can write that as 4s. So if they already told us that the perimeter is 12, 12 equals 4s. So how much each side is going to equal what? 3 meters. Because I would divide by 4, and find that s is equal to 3. Again, they told us I have to know my formula. They've given me one piece of information to plug in, so I have to solve for the unknown. And remember what my question says, what is the length of a side of the square? We found that it was 3. Be sure to stop me if you have questions. All right. The radius of a circle is 4 inches. What is the circumference of the circle? So I know I'm looking for circumference, so I know I'm going to have to use my circumference formula. They've told me to use 3.14 for pi. My radius is 4. So if I know that my circumference formula is circumference equals 2 pi r, then I can plug in where I've got C equals 2 times 3.14 times 4. So when I multiply all of those out, I end up with 25.1 inches squared. 2 times 3.14 times 4. And again, use a calculator, okay? It'll take you forever with a lot of these doing computation if you try to write them out. Okay, let's take a look. So in this section, finding perimeter, circumference, and area. Let's look at number 20. What do I have here? I've got a circle. I mean, I've got half of a circle, right? So I can see, and this is obviously not going to be perfect, but if I had my whole circle, it's just wanting to know what half of the circle is. So it's asking for the circumference. Okay, so all the others, so obviously on my circles, I'm finding circumference. All right, and so it says to use 3.14 for pi. So in this situation, I only want to find half of my circumference of my circle. So what I'm going to do is I'm going to start out by finding the whole circumference. Okay, and we said that we know that C is equal to 2 pi r. They've told me that my radius is 8. So I'm going to have 2 times 3.14 times 8. Okay, so when I get there, 2 times 3.14 times 8. Do the right thing. Well, 0.14 times 8. Hold on a second, let me see. So it says find the perimeter and the area. Okay, so I was looking at my numbers in my book and I was like, well, wait a minute, what is this? So in this one, if we have, for some reason that's not coming out right with what my book has, but if you're using the formula, and we find if we were doing the whole entire circle, we would have 2 pi r. So we'd have 2, 3.14, and our radius it says is 8. Let me make sure it's not calculate that. Surely they wouldn't be counting that as the diameter. So So if we've got 2 times 3.14 times 8, that's going to give us 50.24. Then we would have to divide that by 2, and that gives us 25.12. And that would be, I guess, just units since it doesn't tell us.
Do you have to add the diameter too, since it would just be half the circle, and then add the diameter to it to get the full circumference or perimeter of the half circle?
Yes. So what we've got to do is finding this part of it. We found that, but now when we go here, what are we gonna? So tell us. So what we've got to do is make sure that we've got that side accounted for. Okay. And so now we found what it would be half of that. Now we've got to include that in. And so what is now we know that the radius is 8, so now we've got to add 16 in that. One of the things I'm noticing is then we can just round to our nearest tenth. I mean, it wouldn't be wrong to go ahead and say, because when I add this together, I've got 41.12, but I could just round that to 41.1. Okay. So good thinking not to forget that side that we know. And that's what I was trying to do, the circumference, but then I had to add that side in, okay? So what we had found here, the 25.12 is going to be our curve. But then we had to go ahead and add that side in too. So again, like I said, it's thinking beyond what we're used to doing. Okay, all the other ones are pretty straightforward. You're going to be using your regular formulas. Now let's think about finding the area of that figure. Okay, so area is going to equal pi r squared. So we know that area is going to be 3.14 times the radius, which is 4 squared. So we're going to have area equals 3.14 times 16. 3.14 times 16 is going to be 3.14 times, why did I put 4 in for the radius? That's an 8. I kept going, what am I doing wrong? That's an 8 right there. So 8 times 8 is 64. That looks terrible. Let me get that. 8 squared. 64. Okay, so 3.14 times 64, but remember we're only talking about half of it, so that's 200.96. So we need to divide that by 2. And so our area ends up being 100.48, but again, we could round that to 100.5 square units.
Where did you get 8?
Where'd I get what?
8.
Right here in my problem. It told me.
I thought you were doing 12 for some reason. I was looking at.
No, I'm sorry. No, I'm sorry. I didn't have enough room to do the area for this same problem. We were still doing 20. We had found the circumference down here, and now I was finding the area. I just needed space to write. Any questions on that? So once you use your formula, kind of going beyond thinking about, well, we're dealing with half the circle, so each of these I'm going to half it. But as we saw with perimeter, then I also have to think about adding in that length. We do have at least one straight line on that. Okay. So you will be doing evens. This is on page 55. I'll write it in a different color. So we would be doing 10 through 18 evens on this page. And we're going to turn the page. And we will, let's see, it says find the area of the figure described. So on these, if you want to draw your pictures, feel free. Find the area of the figure. We're doing the same thing with 27, 28, and 29. Draw the figure in a coordinate plane and find its area. And then, so what we will do is we will do numbers 22 through 36 evens. Okay, so let's look at 34 and 36. We just have a problem dealing with carpeting. How many square yards? I want you to notice it says square yards of carpeting are needed to carpet a room that is 15 feet by 25 feet. Do your conversions first. 36, Millennium Dome. The largest fabric dome in the world, the Millennium Dome, covers a circular plot of land with a diameter of 320 meters. What is the circumference of the covered land and what is its area? Okay, so think about using that diameter of 320. You're going to be finding the circumference and the area. Okay, also think about a dome in that one. Think about a dome as not a complete circle, right? So think about that problem that we practiced with in number 20. All righty, let's see. And then let's go and do 42 through 48 evens. And that is on page 57. Righty. Now let's flip forward. Okay, here's our chapter summary. What did you learn? Find and describe patterns. This is section 1.1, and it shows us over here why a pattern, use a pattern to predict a figure or a number in a sequence, and it tells us what page to look on. Inductive reasoning, defined and undefined terms, sketching intersections of lines and planes, segment postulates and distance formulas, angle postulates and classifying angles, bisect a segment and bisect an angle, identify vertical angles, linear pairs, complementary angles, and supplementary angles, and then perimeter, circumference, area, and using general problem solving plans. These two right here will not be on the test. I will give you a separate assignment on those after, because since we just covered that material today, I want us to have a little more time to be able to talk through it and work on it before I test you on it. Okay, so what we're going to do is we're going to start looking at what will be on the test. Okay, so this starts on page 60. Chapter 1 review is on page 60.
I need your consent on a few items.
And I've gone over on our break time. I'm sorry, guys. Let's go ahead and take a 5-minute break, and then we'll come back and talk about this. All righty. So let's kind of go through these. The first thing, notice the vocabulary. We've gone through a lot of words in this chapter. Okay, so let's kind of scoot through this for a minute. Conjecture, remember that's where we're kind of making an educated guess. We're telling what we think an outcome is going to be. Inductive reasoning is by using our reasoning to induce or to think through, to decide what something's going to happen. A counterexample is going to be an example that disproves something. It shows that something maybe is not true. We talked about definitions and we talked about undefined terms. We talked about how there are certain undefined terms that we just kind of accept as truth. And we talked about our undefined terms that we talk about in geometry is going to be a point, a line, and a plane. Okay, those are undefined terms. Collinear and coplanar. Collinear, 2 points on the same line. Coplanar are going to be 2 lines in the same plane. A line segment has 2 endpoints, and that's our next word is endpoint. It has a beginning and an end. Endpoints are going to be those 2 points that create a segment. A ray is going to have 1 endpoint, and then it's going to have 1 end that has the arrow on it that shows that it goes out indefinitely. And also when we name our ray, we're going to name it by the endpoint letter first, and then the other letter, and we draw our little arrow on top of it, our one-sided arrow. Initial point, like when we're naming a ray, our initial point is going to be that first one. Opposite rays, we talked about how 2 opposite rays go in 2 different directions. They have arrows and they meet at that point in the middle. And to intersect or intersection means that they are crossing over. Okay, so we talked about how lines can intersect, rays. We can talk about planes also intersect. We know that 2 lines will intersect at a point, and 2 planes intersect at a line. So we talked about intersection of points and lines and planes. Postulates or axioms. We talked about how our postulates are going to be pieces of information. They're going to be kind of some guidelines, things that, that we use to help understand the relationships of these things. A coordinate is going to be our X, Y numbers that we plot on a grid. Distance and length. Okay, when we talk about distance, if I jump down a couple, we're talking about distance formula. So we know distance is from one end to the other. And we know that if I don't have a perfect straight line to be able to measure the distance of something, I have to use my distance formula. When we talk about things being between, okay, that just means that I have a beginning and an end. I've got something that's in between, okay? When we talked about, when we get to midpoint in a minute, we'll talk about how a midpoint is going to be a point that is between 2 points, but it's exactly in the middle. Okay, so that's the difference between saying betweenness and midpoint. Is between could be located anywhere between the 2. Midpoint's going to be exactly in the middle. We talked about distance formula. Remember that the order does matter. We've got the square root of x2 minus x1 squared plus y2 minus y1 squared. Congruent segments, remember these are going to be congruent, means that they're the same length, they match. An angle we talked about is where we have 2 rays that that touch at a vertex. Okay, so we have 2 rays and they meet at a vertex, and we call our 2 rays the sides, and then the vertex is that point that meets. We talked about being able to name a ray or name an angle. We can name it by its vertex, or we can name it from the beginning, from any of our beginning to middle to end points for our rays. All right, congruent angles. We know that congruent angles have the same measures, okay? The measure of an angle is going to be, remember we talked about using the protractor, and that we can use the protractor to show how many degrees an angle is. We've also talked about, we'll get there in just a minute. The interior of an angle is going to be what's on the inside, what is going to be between the rays. The exterior will be what's on the outside. Acute and obtuse angles. Acute, we know, are going to be little angles, and they're going to be less than 90 degrees. Obtuse, greater than 90 degrees. A right angle is exactly 90 degrees, and a straight angle is 180 degrees. Adjacent angles, remember we talked about that the word adjacent means side to side. Okay, so they share a side. So adjacent angles are going to be beside each other. Midpoint, like we said, is going to be halfway between. If we have a bisector, if a ray or a line bisects, we know that it is cutting into that, okay? And so our segment bisector, we talked about how bisectors are going to cut things in half. We talked about a compass and a straight edge. We didn't use them, but we talked about them and saw pictures of them. The same thing with to construct or construction of angles and midpoints and things like that. Our midpoint formula, we know that we can use our X and Y coordinates to be able to use the midpoint formula where we have X1 plus X2 divided by 2 will give us the midpoint of our X value. And then Y1 plus Y2 divided by 2 gives us our Y coordinate for our midpoint, okay? So midpoint formula, we're thinking about an ordered pair on our coordinate grid. An angle bisector, we know that this is where we have a ray that bisects an angle. And when I hear the word bisect, I know that it is going to cut it in half. So that means that whatever one angle measures, the other one will measure as well. And then I can add them together to get the total angle measure. Vertical angles. This is where we have a line that bisects another line. So we talked about how if I've got something like this, okay, and I know that this angle and this angle are going to be vertical angles. I know that this angle and this angle will be vertical angles because we talked about how if it forms that, if they make a V that matches together and they're exactly the same size, that helps me to remember what my vertical angles are. Linear pair. Remember a linear pair is going to be two that come together to make a line. Complementary angles equals 90 degrees. A complement of an angle would be where I would take 90 degrees minus the angle I'm given and solve for the other one. Supplementary angles are 180 degrees. And then if I find the supplement of an angle, I'm going to have to take 180 and minus what I know and solve for my unknown, okay? So there's a lot of things that we've learned, a lot of words that we've gone through, a lot of new vocabulary for you to kind of sort through and think about. If there's any of these that you get hung up on, I highly recommend that you study them. Go through them, because on the test, if it says, find the measure of, if you have an angle bisector and you've got to use your formulas, or you've got to set up an equation to solve for an unknown, you need to know that bisect means that these two things are going to be equal, so I'm going to be able to set up one thing is equal to the other. Or if it says that two angles are supplementary, and I know that the total is this, but I've got a formula that I've got to set up. I've got to add this plus this equals 180, okay? So knowing that vocabulary is going to help you for when you're taking the test, okay? I was going to say, I think I lost April. Here she comes.
It just kicked me out.
It's fine. I'm sorry. Get you back in.
Like your connection was going crazy. I'm like, and it kept on pausing. Like, let's see
Yeah.
if it does again. So it just finally paused. I'm like,
Okay, it's fine. Yeah, anytime that happens and you have to go out, just, we'll get you back in. All right, so in section 1.1, patterns in inductive reasoning. Okay, we looked at, maybe it's looking at a list of numbers and trying to figure out how those numbers are related. 5, 12, 19, 26, 33. When I'm looking at those numbers and I'm trying to figure out, okay, what is the relationship between these numbers? And I can say, well, how do I get from 5 to 12? Well, I can add 7. From 12 to 19, I'm adding 7. 19 to 26, I'm adding 7. So I can see that as long as my pattern works for every single, given example, then that's my pattern. Number 2, I go from 0 to 6, 4, 30. This one looks a little more confusing. And so if you look at it, thinking about how to get from 0 to 2, well, I know that I can add 2. And so, but when I go from 2 to 6, I'm not adding 2. And so I've got to think about what am I doing in this one? And the numbers after the first are found by adding consecutive powers of 2. Okay. So, so if I've got 2 to the first, 0 plus 2 to the first gives me 2. Then 2 plus 2 to the second gives me 6. 6 plus 2 to the third gives me 14. This one's a little more challenging. 14 plus 2 to the fourth gives me 30. Okay, so that one's a little more challenging there. Number 3, 4, 12, 36, 108. Again, on this one, to get from 4 to 12, I know that I could either add 8 or I could multiply by 3. I know that getting from 12 to 36, if I add 8, that's not going to be enough, but I can multiply by 3. Again, 36 times 3 is 108. 108 times 3 is 324. So finding those patterns, okay? Same things with sketching the patterns. On the test, I think it's going to mainly be looking at number patterns. I don't think we have any picture patterns that we have to worry about. Let's go ahead and look at 1.2 review. Points, lines, and planes. So it says C, E, and D are collinear. We can see that they're all on the same line. Line CD is a line, AB is a segment. And so we can see CD has our arrows on the end, it forms a line. AB has 2 endpoints, so we can see that that is a segment. A, B, C, D, and E are coplanar. They are all located in the same plane. Ray EC and ray ED are opposite rays, and we can see where those opposite rays meet at point E to form a straight line. Okay. All right, and then it says there's some examples here. As far as the chapter review goes, I'm going to leave that to you to do. If there are any chapter review things that you feel you need to do to prep for the test, I'm going to leave that for you. I'm not going to assign the chapter review. We're just talking through the things that you need to know how to do on the test. So if there's any of these that you feel like you need to practice with as we're going through this review, I want you to highlight, star, write down, do whatever you need to do to say, hey, I really need to practice this a little bit more, okay? 1.3, segments and their measures. This is where we have our distance formula, okay? And so we have to be super careful as far as dealing with positives and negatives. And so we'll go ahead and highlight distance formula right here. So you know that that is something you need to know. You need to know the distance formula. It will not be given to you. You have to have it memorized. So make sure to make a note of that. Angles and their measures. Understanding that, let's see, I was trying to see if it says 1, 4, okay. This right here is going to go along with our angle addition postulate. And this is found on page 27, where it said that if I have 2 angles like 60 and 45, I can add those together to find my total measure of this outer angle. Okay, I can add angle 1 and angle 2 together to get my total angle. Same thing here. If I see my little box, I understand that this is 90 degrees. So then to find my unknown, I would have 90 minus the degree given. Same thing here, understanding that my straight line is 180 degrees, so I would need to subtract what I'm given to find my missing measure. And this is based on the angle addition postulate, understanding that I can add 2 angles together to show the total of the larger angle, or I can take the total of the larger and subtract 1 to find the other. Okay, Easton?
Will you create a test, or are we gonna use a chapter test like in the book?
No, this is the book, the one that's in the book. It's a different one. I think this is just the chapter, what they've given you is just to give you an idea of what the test is going to look like. that will give you, because it does not, it's not comprehensive. So no, it will not come from that. All right, 1.5, segment and angle bisectors. Again, talking about bisectors. Turn to 1.5 real quick. We know that a bisector intersects at a midpoint. Okay, so I know that if it bisects at a midpoint, I know that that word midpoint is halfway. So a bisector cuts it in half, okay? So here, notice that this part, we're using midpoint formula, okay? Again, they're not giving you the blank formula here, but you need to know your midpoint formula. You need to know that you've got X, whoops, see if it'll give me enough room to write. X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. Midpoint formula. You need to know that. Okay. Again, here it's telling me that my ray is a bisector. So whatever this measure is going to be equal to that one. Here, if I know my entire ray is 50, I can divide by 2 and know that each of these is 25. Here, I've got, notice that it does not have the little box, so I cannot just look at it and go, oh, well, it looks like a 90-degree angle. I can't assume that it's a 90-degree angle because it does not have the perfect square. And also notice that this is 46 degrees. So that means this one will be 46 degrees as well. So it's just a degree over being a 90-degree angle. All right, 1.6, angle pair relationships.
Miss Jennifer.
Uh-huh.
The homework that you assigned us, is that all of it for the week?
We'll be talking a little bit more about studying for your test, but yes, it'll be doing the homework that I assigned and then prepping for your test. Okay. And so,
Okay.
And it may be whether you need to make yourself some notes based on what we're talking about right now. You know, if you kind of create yourself a little study guide of what you need to study, or if you're doing the chapter review, it's going to be up to you. What I'm trying to do is, I'm trying to give you a guideline and trying to help you take a little more personal responsibility in your learning, okay? I don't want to just lay it all out like we've done in pre-algebra and algebra 1, and I say, do this, do this, do this, do this. Because what our ultimate goal is for you to become a more independent learner. And eventually, if and when you get to college, they're not going to give you, I mean, you know, you're taking notes, you're figuring it all out on your own. So what I'm trying to do is what we call scaffolding. So I'm trying to kind of raise you up to where you're taking some personal responsibility for this stuff. I'm going through this study guide and telling you what you need to know. What my hope is that you're going to take this information and say, hey, I'm good with this. I'm good with this. Hey, I need to learn these formulas. I'm going to make myself a note to study these formulas. Okay. So this is what my hope is that you're going to go through this and say, I'm going to focus on the things that I need to work on. And then that's what you're doing over the next week for homework. Okay. But we'll talk more about that at the end. Angle pair relationships. Okay. This is where we were talking about vertical angles. Okay. So we know that vertical angles would be like 1 and 3. All right. The others cannot be vertical angles because remember, vertical angles are equal to each other. Linear pairs, that's going to be where we have the pairs of that make a straight line, and then supplementary angles. We know that supplementary angles are 2 angles that add together to make 180. So in this situation, supplementary angles, 3 and 2 would be supplementary, okay? Now actually I could add 1 and 4 and then the one in the middle to equal 180, okay? complementary angles, 90 degrees. So we know that when we're talking about vertical, we've got vertical, linear pair, supplementary, and complementary. Complementary angles add together to make 90 degrees. So if we look here, if we know those two are going to make 90 degrees, okay? Because this guy over here is 90 degrees, so we know that whatever these add to plus this makes 180. All right. Perimeter, circumference, and area, and that's what I said we would not be testing on. I will be giving you an assignment on that at the end of next week, but we will not have it on the test. Okay, so the things that we've just talked about are going to be to go through and make sure you know. So let's take a look at that for a minute. Let me go back and get a blank piece of paper. So you want to make sure that you know your vocab. You're going to want to make sure that you know that distance formula. You want to know that you know the midpoint formula. You're going to want to make sure that you know angle addition, postulate. So basically, what you're going to be looking at is your vocab and all the green boxes. Okay, because the green boxes are where we find all of our formulas. So as you're flipping through your textbook, you're wanting to make sure that you're focusing on your green boxes and your highlighted vocab. Okay, so I think that's a good guideline on what you need to study for. Like I said, if there are certain things that are not sticking in your memory, make flashcards, okay? Put midpoint formula on one side, write the formula on the other, and then that way you can look at it and you go, oh, midpoint formula, that is da-da-da-da-da. Flip it over, check yourself. If you got it right, then you put it off to the side. You don't worry about studying that one anymore. You study the ones you don't know. If you're getting your X1 and Y1 and X2 and Y2 confused, keep practicing it. Same thing with distance formula, okay? Any questions? All righty, so let's look real quick back at what we said was homework and make sure we've got all that written down. All right, so let me find my little sheet. Okay, so for today is 8/27. We will have page 55, numbers 10 through 18 evens, and then 22 through 36 evens. Then we're going to have page 57, 42 through 48 evens. And that is it. Okay, page 55, 10 through 18 evens, and 22 through 36 evens. And then page 57, 42 through 48 evens. And then study for your test. Go through, study your vocabulary. Study the green boxes. Memorize your formulas. Okay. Any questions? We are done early. So if you're ready to go, you're welcome to go ahead and go. If you need to stick around and ask questions and get help on something, please don't hesitate to do that. I will be here hanging around if you need to. But just know that, so next Wednesday, we should be back at the co-op. Everything is on sale for being back at the co-op next Wednesday. I'm sure that they'll be sending out the guidelines for that. We have not heard anything as far as the state mask mandate that's supposed to expire on the 31st. My assumption is that they're going to keep it in place because it seems to be working. The numbers are down. I don't know what the rule will be at the co-op as far as like as long as you're sitting in your seat. I don't know if masks will be able to come off. I don't know how that's going to work yet. So just be looking for emails from the co-op on guidelines for that. If you are not able to make it to class, I'm going to still have this same format. So what my plan is, and I make lots of plans and sometimes they don't exactly all work out, but just so you know, what I'm planning on doing, since we're going to be in class 1 week and back home 1 week, I want to go ahead and keep teaching by this same format we're using. I don't want it to change for the classroom and change for here. So actually what I've done is I've ordered a projector. So in the classroom, my plan is to still work off the iPad like I have been doing, but it will just be projected on the screen. So on the screen, I won't be writing actual notes on the board. It's all going to follow this same format. So that way, if you're home that day or if you're having to watch the video, it's all going to be shared on my iPad screen just like it is. You'll use the same Zoom logins to log in, okay? Everything will stay the same in that format. It'll just be that some of you may be in the classroom and some of you may be home. So it's the kind of thing where I wanted it to be as consistent as possible because there may be days that some of you are not able to come in, and that is fine. I know that there's all kinds of, every family has different issues going on, different health concerns, different family members that you're having to be concerned about and stuff like that. So, so it's the kind of thing where I want everything to be available to everybody in the same format. So everything, like I said, provided I can get the projector to work right, it should be to where I'm just projecting everything on the board in the classroom. I'm just kind of standing in the corner with my iPad, still talking to you guys and working with you guys, but at least I'm there to help you in person, but I'm kind of following the same format. Okay. So, we will figure it out though on Wednesday, and make sure that it all, you know, goes hopefully as seamlessly as I plan for it to be. Okay. Claire?
Is the homework due next Wednesday?
So the homework will be due next Wednesday, and I do want to mention that we will still be uploading homework just like we have been doing. Okay, so even if you come to the co-op on Wednesday, I'm expecting that your homework is uploaded before you come to class. Okay, I think that's going to be easier to remain consistent with that as well, so you don't go, ooh, was I supposed to upload this week or not upload, or when, you know. I'm just planning on, it's easier for me in grading when y'all upload it. Plus, I think it's going to be more consistent and less confusing for you if we follow the same format. Okay, so we're still going to upload all homework even if you come to the co-op. All right, I don't want to have to worry about shuffling papers and keeping up with who's turned in what and things like that. So the upload thing, blessing in disguise, I guess. It's working well, I think. Okay.
So we're going to continue to upload all our stuff virtually?
You'll still plan on uploading all your homework, yes. But then when we come to class, you'll actually, you know, when we go through the homework answers, you'll have your papers in front of you to circle and mark and make corrections on and stuff like that. So, so you'll, you know, we'll still check it and you'll have your papers in class. So still bring it to class. Just because you upload it doesn't mean that you don't need it in class. Bring it, because when we go over homework answers, you know, you're going to need it to check your work. Okay. So bring everything like normal, but just have it uploaded before you come to class. Okay. Or if it's the kind of thing where, I understand with us being an 8:30 class, if it's the kind of thing where you get to class and you haven't uploaded it yet and you have to take quick pictures real quick, I just want it uploaded before we start going over answers. That's the main thing. It's like if you get to class and go, oh my gosh, I forgot, and you've got that app scanner on your phone, take pictures, upload it real quick, get it in there. Okay. Any other questions? All righty. Well, like I said, if you need to hang out and ask questions, feel free. If you do not, you are welcome to go. All
Bye.
right. Bye, guys. See y'all next week.
Thank you.
You're welcome. Thank you.
I was muted. Sorry. Bye. Thank you.
You're so welcome. Hey, and like I said, I'm planning on doing everything kind of same format. My biggest concern is figuring out when you have questions. So we'll kind of work with that, because when I'm sharing my screen on my iPad and I'm working, I'm not able to see you. And I'm planning on having it projected from either my computer or my phone. So I'm not real sure. So I might need you to yell out if you need help.
Okay. Yeah,
Okay.
that makes sense.
All you've got to do is just say, Miss Jennifer, and I'll pause,
Okay.
you know. So I want it to be, but I also don't want it to be uncomfortable for you. So again, it's the kind of thing where if you would rather ask me questions at the break, or if you'd rather, you know, whatever, we'll work out a plan and see what's going to work for that.
Yes, ma'am. Thank you. Either way is fine with me. I'll just make sure that I talk to get your attention.
Yeah. Because I'm just worried that if you raised your hand or something, I may not see you. I'm not real sure what the setup's going to look like till I actually get it set up. So, but I just want you to know that if you have questions, please be sure to let me know. Okay.
Thank you so much.
You're welcome. All right.
Have
See
a
you
good
next week,
week.
babe. Have a good week.